There we go. All right, so what we're going to do first is I'm going to put this as our P over Q. So I'm going to put this into where we have common denominators, because that's a little bit easier to work with on a lot of the things. So we're going to take our 2 over here, and we're multiplying it by x minus 3 over x minus 3, right? So that we get to that common denominator. So we're going to have x minus 3 in the denominator. And we have minus 2x plus x, giving us minus 1x. Minus 2 times minus 3 gives us plus 6, right? You see it? Or do we need more steps? We took this minus 2 times our x and our minus 3, and I just combined it together with my x minus 2x.
So you just simplified?
I distributed and simplified in one step.
Can you do it out?
Yeah. Yep. So this gives us x minus 2x plus 6, distributing that minus 2 out. So then we're combining our like terms. We have minus x plus 6 over x minus 3. Okay, so then we're going to see if we can start filling in some of our information at the bottom. Does this have a removable discontinuity or a hole? That's where we have a thing that'll simplify out of numerator and denominator. No, this does not have one. But we should check every time because sometimes they're sneaky. No hole. There isn't one. Our x-intercept, that is our solutions to the numerator. So look at our numerator here. Where are our solutions? Numerator, top. 6. So this is always our solutions to numerator. Our y-intercept, that comes when x is 0. So we substitute in 0. If we substitute in 0, what do we get as a y value? -2. Because 0 plus 6 over 0 minus 3, 6 over -3, -2. Right? That does say solutions in numerator. Yes, sorry. I will write that better. Our vertical asymptotes, those are our solutions to the denominator. We set them as x equals, what is our solution to the denominator? 3. And then our horizontal asymptote, that's when we think about what we did on Friday with that N behavior, where we see if it's top heavy, bottom heavy, or equal. So do we have more x's on the top, more x's on the bottom, or do we have an equal degree? We have an equal degree. So that's when we take our leading coefficients And that's what sets our horizontal asymptote. Y equals our leading coefficients. We have -1/1. So our horizontal asymptote is at y equals -1. So we have a whole lot of information, and we're going to take that whole lot of information and put it all on our graph. So I'm going to just work my way down. We're going to put some points. We're going to put some lines. We're going to see what we got. So I don't have a hole that I can plot, but I have an x-intercept at 6, 0. So I'm going to put my point. We have a y-intercept at 0, -2. So I'm going to put that point. We have a vertical asymptote at x equals 3. We draw those with a dashed line or a dotted line. And then we have our horizontal asymptote at y equals -1. And this is actually enough to get our whole graph in here on this one. Okay. From here, what we know is we know our graphs hug these asymptotes. They get real close. Real close. Real close. So we have a point in each of our spaces here that shows us what our function's going to look like. And it's going to look like that. If you want to pick some more x values and substitute in to get more points, you absolutely can. And if we have a region or a space on our x-axis that doesn't have a point, that's exactly what we're going to do to find one. But between our x-intercept and our y-intercept on this one, we had enough information. Okay? So questions on the first one? And that's kind of the vibe. We're just going to work our way down the checklist. We're going to get all the information we have. We're going to find some points. We're going to plot them up. All right? And that's what we're doing with the next, all of them. So here's the next one. X squared minus 4 over x squared minus 2x minus 8. So our first step is going to be to factor both of those, see if we have any holes. So we'll write this in our factored form first. And this is the difference of squares. So x plus 2, x minus 2. Our denominator, I'm going to go ahead and do my x from to c. We need a pair of numbers that multiplies to make -8, adds to make -2. -4 and +2. My a value is 1, so we can hop straight into factored form. X minus 4 and x plus 2. That is a minus. It looks like an underscore, but it's a minus. All right, so do we have a hole here? Where? Wherever x plus 2 is the solution, right? So what is the x value of the hole? -2. How can I figure out the y value of the hole? So we're going to take our -2 and we'll substitute into our leftover bits. So -2 minus 2 Negative 2 minus 4. So negative 4 over negative 6, positive 2/3. So we can write that as a point there. I'm going to write our leftover bits. Yeah, so we're taking our leftover pieces over here, my x minus 2 and my x minus 4. And we substituted in that x that gave us the whole. We substituted in the negative 2. Negative 2 minus 2 gave us negative 4, and negative 2 minus 4 gave us negative 6. Negative 4 over negative 6 simplifies down to be positive 2/3. Our x-intercepts are the remaining solutions to the numerator. So what remaining solution do we have? 2. Positive 2, 0 is going to be an x-intercept. It's the solution in the numerator. My y-intercept, that's what happens when x is 0. When x is 0, what is my y? 1/2. Because it's negative 2 over negative 4, which simplifies down to be positive 1/2. Our vertical asymptote, that's where our denominator stops working when our denominator equals 0. So our vertical asymptote happens when x is what? 4. Our horizontal asymptote, that's when we're looking at the strength of it, our power of it. We have an even number of x's, top and bottom, so we look at those leading coefficients. So we're going to have y equals 1 over 1, also known as y equals 1. So we're going to plot all the information we have. We'll get all our pieces up here. So negative 2, positive 2/3 has a hole. So make sure you put that as an open circle. We have an x-intercept at 2, 0. We have a y-intercept at 0, 1/2. We have a vertical asymptote at x equals 4. So we're going to draw that in. And we're going to have a horizontal asymptote at y equals 1. So I can see part of my shape. I can see that this side is going to look something like this because we always hug those asymptotes. Do we know if this is going to be down here or up there on this right-hand side? No, we don't. So we're going to have to select an x value from over here and substitute it in to find a point. Figure out where it is. So you can pick anything that we have over here that's on our graph. It really doesn't matter. 5. So we're going to evaluate f of 5. So that we can find a point on this right-hand side because we don't have enough information over there. We really only need one point. And you can either use the full equation or our simplified equation. It doesn't matter because the whole's not going to have any impact on f of 5. So we can use 5 minus 2 over 5 minus 4. 5 minus 2 is 3. 5 minus 4 is 1. So we get a point when x is 5, y is 3. So that gives us another point, 5, 3, and now we can see exactly where our curve is going to be because it hugs our asymptotes. Should be curve. Okay? It's just a matter of remembering all these zillions of things we did Wednesday and Friday. But that's all it takes is a little bit of practice. Okay. Boop. Next one. All right. So we're going to start with seeing if we can factor stuff. Well, my numerator doesn't factor. It's just an x. Let's see about this denominator. Do we have a pair of numbers that multiplies to make -2 and adds to make -1? Yeah, -2 and +1. So this is really x minus 2, x plus 1. I always recommend starting with your factoring. See if we can get things simplified. Does this one have a hole?
No.
Nope. There is nothing that simplifies out to make a hole. All right, x-intercept, solution of the numerator. Where do we have an x-intercept? 0, 0 is an x-intercept. How about a y-intercept? 0, 0. That's what happened. We check that by substituting in 0. 0 is our numerator. 0 over anything is 0. So our x-intercept and our y-intercept are the same here, and that's okay. Our vertical asymptote are solutions of the denominator. What do we have? We have 2 of them. X equals 2 and x equals -1. We have 2 vertical asymptotes. For our horizontal asymptote, we look at our strength over here. I have more x squareds on the bottom than on the top. So if we think about this as having 0x squareds, our ratio of our leading coefficients, 0 over 1. Y equals 0 is our horizontal asymptote. Because we don't have any x squareds on the top, and when we're looking at our horizontal asymptote, we look at the ratio of the leading coefficients of our biggest degree term. And we don't have any x squareds, so it's a 0. You can also remember that if it's bottom heavy, it's always going to be y equals 0. If I have x squared on the bottom and no x squareds on the top, it's always going to be there. I just feel like sometimes it's easier if we have a rule. as opposed to just memorization. But if you want to just memorize it, I'm okay with that. But this has a lot of pieces. Say it again. Look at the ratio of the leading coefficients of the highest degree terms. And that works with this one. We have 0 over 1. It worked when we had 1 over 1. And it'll give us a clue on the when we have the top, because we'll have something over 0, which means we're going to need to do some division. Okay, so let's put all these pieces on here. And there's going to be a piece that looks really weird, and I promise it's okay. Because we have our x and y intercepts at 0, 0. Jeez, this grid is really big. Holy cow. I've got my vertical asymptotes at 2. And at -1. And we have a horizontal asymptote at 0. So what we have is not enough information to get a good graph, huh? So what we're going to do is we're going to pick some points, substitute them in, and get some more points to go with. So I would really like to know what happens in these corners. So we're going to pick at least one on either side. And then we're probably going to do something in the middle, because what the heck is going on there? Okay. So we're going to pick some values and substitute them in. So let's start with our outside edges, because they're going to look the most normal. So I'll do f of -10. Let's do it. I was going to say, you give me silly ideas, we're going to run with it. -10. Totally fine. Absolutely valid. So when x is -10, we're going to have 10 over 10 minus 2 gives us 8. 10 plus 1 is 11. -10, yes, 100%. Sorry, not thinking. -10 minus 2 gives us -12. And -10 plus 1 is -9. I was totally just testing us, making sure, paying attention. Totally not at all that I was flying ahead and not paying attention. So we have -10 over something big. 9 times 12 gives us 90 plus 18, so 108. So -10 over positive 108. Okay, so notice how we have our horizontal axis right at 0. Is this above 0 or below 0? Below. Does it matter specifically what decimal it is? No. Is it obnoxiously small because we picked an obnoxious number? Yes. But it's here. That is still enough to say, all right, I know it's hugging below this asymptote, and it's going to be in this corner. So it doesn't matter which value you pick. If you pick obnoxious numbers, though, you may get obnoxious decimals. So it's going to look something like this, because it's got to hug both asymptotes. Let's see what happens in our far right corner, maybe with a slightly less obnoxious number. I know it was him. I heard it come from his face. So let's go with maybe 3 or 4. Something slightly less of a bold choice. 4, let's do it. It's fine. I was like, they might not be pretty anyway, but it's okay. F of, let's do 4. So we have 4 over 4 minus 2 gives us 2. 4 plus 1 is 5. So we have 4 over 10. Is that above my asymptote or below my asymptote? Above. Okay. So then we still need to figure out what's going on in between the asymptotes. So let's go with our whole number that's not been used yet. Let's use 1 that's in between here. So let's do f of 1. So we have 1 over 1 minus 2, which is -1, and 1 plus 1, which is +2. So 1 over -2, right? So when x is 1, y is -2. That gives, no, I'm sorry. When x is 1, y is -1/2, which gives us a point right here. So what that shows me is that from that x-intercept, it's going to go through this point and against this asymptote. It also shows me it's going to go through that point and against the asymptote. So it also shows me my other side. So when we have two vertical asymptotes, you're going to wind up with what looks like a tangent curve. Did you guys ever do graphing tangents? It's going to look like a tangent curve when you're in between.
Why are you allowed to cross the asymptote? Miss,
Hang on, sorry, my screen glitched.
did you connect the last one with the...
So when we had this point, that shows me it went through my x-intercept down through this point, and it gets close to my asymptote and it doesn't cross it.
Why are you allowed to cross the horizontal asymptote?
The horizontal asymptote is going to be the only one you're ever allowed to cross. And it's only when you're in between.
Oh.
Okay, the horizontal asymptote also is called sometimes your end behavior asymptote. So it's really only affecting your outside ends. So in between, you can cross it. It's not super common, but it's a thing. So just be careful. When in doubt, substitute in more values and give yourself more points. Okay? All right. Let's do another one of the kind of weirdy ones, because I want to make sure we do one of these together in person, because they get a little weird. All right. So on this one, first things first, let's see, does it factor? No. It does not factor. Do we have to do the quadratic formula to find intercepts? I mean, it's worth a shot. So, if it won't factor, is there going to be a hole? No. Because a hole has to simplify out numerator and denominator. So, if it won't factor, all that tells us is we're not going to have a hole. To get our x-intercepts, that's when we got to use our quadratic. So we're going to use the quadratic formula to get x-intercepts. So we're still looking for those solutions of the numerator to find the x-intercepts. So to find our solutions, we can use our quadratic formula. The opposite of b plus or minus the square root of, this is something that a lot of people forgot, b squared. I don't know why a lot of people forgot that square, but some of us forgot that square. It should be 36. Minus 4ac. I also had a couple people forget the 4. 4 times 1, which is 4, over 2a. 2. So we have -6 plus or minus the square root of 32. Bless you. Can we simplify the square root of 32?
4 squared.
16 and 2, so it becomes 4 square root of 2. Can we simplify this more? Yes, to what? Negative 3 plus or minus 2 square root of 2. Great, where are our roots? Not particularly helpful, huh? But how many roots do we have? 2 real roots. So we know it's going to cross our x-axis twice. Because I have 3 plus a real number and 3 minus a real number. If we really wanted numerical answers, we could. It's gross, but we could. We could type it in our calculator, which would be better. But it doesn't particularly matter. We can plug in easier numbers to get actual values when we need points. Okay, having this, that tells me we have 2 real roots. If you want to get a decimal estimate, you can absolutely do that, but I am okay with us just having this. Because it's gross, it's a thing, all it tells me is we have 2 places where it crosses my x-axis. And they're going to be at decimals, they're going to be irrational. All right, so let's find our x-intercept and move on from the grossness. Or our y-intercept, excuse me. Y-intercept happens when x is 0, so where is my y-intercept? Zero plus 1 over 0 plus 4. 1/4. That's a lot easier to deal with in graph. Our vertical asymptote, that's what happens when our denominator is 0. Where is our vertical asymptote? X equals negative 4. Now we're looking for that end behavior asymptote. What do we need to do here? I say check our ratio of our leading coefficients, right? See if it's easy. I have 1x squared on the top. How many x squareds do we have on the bottom? 0. So a vertical asymptote would be, it would be undefined. That doesn't fly for us, so we need to do slant, which means I need to divide those. I need to actually do the division. Synthetic or long division to divide this out. I need to know what my quotient is. I'm going to do synthetic because it's smaller space. So I'm going to do it in this kind of little nook that I left me. So I'm going to take my coefficients of 1, 6, and 1. And we're dividing it by the root of our denominator, negative 4. First term always drops. Multiply against the negative 4 and add those together. 2. Multiply against the negative 4, add them together. The remainder doesn't actually mean anything. I just don't like to leave problems half done. We don't need the remainder for anything. All we need is the line that we have as our quotient. So this is 1x plus 2. 1x plus 2. So our end behavior asymptote, what's going to be our horizontal asymptote, is where y equals x plus 2. That's our slant asymptote. So let's graph that line. Y equals x plus 2. I'm going to start right there. So the line y equals x plus 2, how do we graph that? It's been a hot minute since we graphed a line, so let's remember. Our slope is 1 over 1. Where do I start? 0, 2. My y-intercept of 2. Slope of 1, up 1 over 1. I recommend using a ruler highly. My screen gets super grumpy about rulers. That is our slant asymptote. So it should look something like this. We also have a vertical asymptote at x equals -4. Bless you. I've got a y-intercept at 0, 1/4. And we know it has to go through that point and hug both asymptotes, right? So it's going to go through this point and it's going to hug my purple asymptote. And it's going to go through that point and hug my green asymptote. Okay. Left-hand side, I don't have a point for where it's going to be. So we need to pick a point to substitute in. Or we could make the realization we have 2 real roots, and that gives us a big old clue as to where it is going to be. But let's substitute a value in and find something.
How do we get the value in black? Like the line in black?
Because it went through the pink point, and it hugs both asymptotes. So we know it's not going to like zonk into a corner and dead end. But you can always pick more values to substitute in. So let's pick something left of my vertical asymptote, maybe -5. And we can substitute that in. So let's do f of -5. And we can do -5 squared, which is 25, plus 6 times -5, so -30. Plus 1 over -5 plus 4, which is -1. F of -5, 25 minus 30 plus 1 over -1. So it becomes +4. So when x is -5, my y is +4. And again, I have a point, and I know it's going to hug both my asymptotes. So I'm going to go through that point and hug the green asymptote, and through that point and hug the purple asymptote. We only get to cross asymptotes when we are between. If it's got 2 vertical asymptotes, okay? We have 2.5 minutes left in the period. So we will finish these up tomorrow on the Zoom call. We'll do as many as we can. I will get the answers for all of them posted. We'll probably start with the last one and work our way backwards because the last one's kind of weird looking. Yes, dear. X was -5. Y was +4. Yes. So it gave us the point -5, 4 as a point. Okay? So, yep. Just putting it up because y'all get super cranky if I don't. So tomorrow, e-learning day. Make sure you come into the Zoom. We'll work through more of these. I do have to take your attendance, so please use your Chromebooks, not your iPhone. We'll work through more of these. I will also post them up as a PDF in case we don't make it to Zoom calls. I will be totally shocked that everybody does not come to the Zoom calls. Oh my gosh. I was gonna say we only have 2 more graphs in like a paragraph, so it's not like super lots.